Students, बात चल रही है about the connecting devices and we are talking about the first one which is a physical layer device and that is called a hub. Students, जैसा कि मैंने आपको बताया था कि hub जो है it is typically a physical layer only device, so and it does not do any sort of filtering. It does not have a physical address, it does not have a link layer address, and therefore it does not recognize or read through the link layer addresses or physical addresses as well. Whatever comes in, it actually gets broadcasted out through all the output ports, whether it's an acceptable signal or it's noise. The hub regenerates or repeats the signal and then sends it out. Students, in this particular slide, you can see a hub that is connected to 4 different stations A, B, C, and D in a star topology. Students, मैंने आपको बताया था कि Ethernet LANs जो हैं, they use star topology, and in the star topology, your hub or a repeater, it's a multi-port device, and it can be used to serve as the connecting point and at the same time serve as a repeater as well. So this hub in a star topology that I'm showing you, it is not only behaving as a connecting device, but it's also acting as a repeater. Now, students, hub is a dumb device. Hub does not know how to do filtering. Hub does not know how to filter based on the destination link layer address, and therefore whenever something is sent to the hub, for example in this case your station A sends some data to the hub, and what the hub does is it just takes this data, uses a repeater to regenerate the data if the signal strength is weak, and then it sends it out to each of the other stations that are connected to it. So the broadcast data, it goes to all the other stations except the sender. Students, when B reads this data, it finds out that the destination address is of B, so it decides to keep this data, and all the other stations, they have to process this, at least the header field, to read the destination address, and when they find out that the destination address does not belong to them, they simply discard that particular data. Only the B keeps it. Students, once again, as I told you, a hub or a repeater, it's a physical layer device. There is no concept of a link layer address on this layer, on the physical layer, and therefore the hub does not check the link layer address of the receive frame. The hub just regenerates or repeats the corrupted bits, and then it sends it out through every single port. Students, the second type of connecting device that we are going to be talking about is a link layer switch, or simply a switch. Students, a switch which is basically a layer 2 device. It actually operates on both the data link layer as well as the physical layer. Students, at the physical layer, it regenerates the signal that it receives if it's degraded, so a physical layer function. At the data link layer, the link layer switch can check the MAC addresses, so media access control addresses. So source and destination, which is contained in the frame, they are read by a switch. Switch is not a dumb device like a hub. Switch is an intelligent device. So as the name indicates, because the switch contains a MAC sublayer at the data link layer, it is capable of reading the link layer addresses or the physical addresses or the MAC addresses, whatever you want to call it, and based on that, the switch does the filtering. If you send some data to a switch, the switch, being an intelligent device, understands where the destination is or what port of the switch is the destination connected to, and based on the destination address, the switch only sends the data outside of the port that is connected, that is connecting the destination to that particular switch. Students, as I told you, switch versus a hub, switch has got filtering capability. Unlike a hub, a switch can check the destination address of a frame, and it can decide on where the frame needs to go via an outgoing port. Students, switch, मैंने आपको switched LAN की बात बताई थी, Ethernet switched LAN. आपने देखा था कि in the case of a full duplex switched Ethernet LAN, we had a receiving link and we had a sending link. So the possibility of collisions happening in the case of an Ethernet switched LAN or a switched local area network is close to 0. And so in this particular case, we do not need any sort of carrier sense multiple access technique. The switch does not need to, in the case of a switched LAN, you do not need to check the medium. You do not need to sense the carrier or to employ any kind of collision detection or collision avoidance. Students, as I told you, switch is an intelligent device, and as you can see in this particular case, the switch that we are using, it is actually building a table that we call as a switching table as well. So what happens is, let's suppose that this switching table was completely emptied in the start. What happens is, this first station, which is your station number 41, we call it, you can see a hexadecimal representation of the physical address or the link layer address in this particular case. So this first station, which is station number 41, it sends the data to the switch. Now students, in the first case, the switch, because it does not know which port the destination is connected to, so when the data comes from A to this switch will actually send it out to all the different ports. So the data is sent out or broadcasted to port number 2, port number 3, and port number 4. All the other ports receive it. So you may ask, a switch is an intelligent device, then why is it broadcasting this data through all the output ports? Students, the reason for that is that because in the first instance, because it's a new switch and we've got new connections, the switching table is completely empty. So in the first case, when A sends the data to this switch will actually broadcast the data out of all the output ports, but it will create an entry in its switching table to say that 71:2B:13:45:61:41 is station number A, and it is connected to port 1 of this particular switch. So that entry is created. Now students, let's suppose this station D, which is your number 13, this one, it actually sends some data to switch to this particular switch. Students, if this data is not destined for A, because we've already got an entry out here, then in this particular case, it will still be broadcasted out through the two links that are left, through port number 2 and port number 3. But at the same time, your switching table, a new entry will be added in which you will have the station D address in there with a port, and the switch will know that if I get anything which is destined for station D in the future, I need to send it out through station to output port 4. And this is how the link layer switch actually slowly and steadily, intelligently, using the filtering capability, it builds a switching table. And then if there is any data that comes to any of the particular switches and it's destined for the stations that are available in the switching table of that switch, that data is straight away transmitted instead of broadcasting that data out.